Hey everyone, in this video I'm going to show you how I use Google Sheets to calculate simulations for player props. I'm going to use Kevin Durant's stats here as an example, and what we're going to do is we're going to calculate simulations for Durant's rebounds. So let's get right into this. So right now I've got his game logs here, and we've got his the TOT, that's just his rebounds. We got assists and points. We're gonna create simulations for his rebounds. So in order to do that, we need two things. You need a projection, which I'm not going to get into building projections here, but you need a projection, whether you create it by a service or make your own, whatever. You got to have a projection, and then you got to have standard deviation. So standard deviation is kind of this. It's like the distribution of like a range of outcomes. So we're going to use Durant's right here, his rebounds. So if we highlight everything, actually let's use the function average. Let's figure out what his average is. Average, and I'm just going to highlight it all and press enter. And there, so his average is 5. So all we did was just calculate the average on this. So that's 85 total, divided by 17 games. So his average is 5 rebounds per game. So assuming this is the bell curve of his outcomes, right here is 5. This is the most common result. Maybe here is 6, maybe here is 7, all the way to like here is, maybe this is 9. See if you can see here that there's a 9 here, there's a 1 here, there's another 9. So that's pretty much the bell curve. Like right here is probably if you get 0 rebounds, here's 1. And here's the bell curve. Not all bell curves look like that. That's why we've got the standard deviation to calculate. So the deviation, standard deviation is just the variation between the average and like where most of the outcomes show up. So in order to do that, we're going to use the formula STDEV.P. And then we'll do parentheses, and all we're going to do is highlight the range. All that's going to do is give you the standard deviation of the population of data, which we just provided it. We press enter, and it's 2.11. So that means, on average, Durant's rebounds are going to fall plus or minus 2.11 rebounds from his average, which is 5. So it's roughly between 3 and 7 is going to be his range of outcomes for rebounds. And if you look at this, there's only 1, 2, 3 of them that are outside their range from between 3 and 7. So 14 of the 17 do fall in that range. So that would kind of make sense for the standard deviation to be a 2.11. So now we've got what his average is, what his standard deviation is, and the range of outcomes. We want to calculate simulations. So to do a simulation, we're not going to use the average, because the average, as you know, is not always the best predictor of what the day's rebounds would be. So we're going to use a projection. And we're going to create this formula here. It's called NORM.INV, NORM.INV. And that's just the reverse normal distribution function. Basically, you're going to need 3 things in order to create the standard deviation. We got a x, which is the random number. So you're going to use rand, and then 2 parentheses. All that's going to do is give you a random number from 0 to 1. The mean, which is his average, or really his projection. And let's say, even though his average was 5, let's say in today's game it's 5.5. And the standard deviation is right here, 2.11. So I'm just going to put 2.11. Into parentheses, press enter. And then we got a range of 6. So how this formula really works is it takes this 5.5, it takes this bell curve 5.5 with the standard deviation of 2.11, and it creates this bell curve like this. And then what the rand does from picking a number from 0 to 1, it tells you where on this bell curve it's going to choose. So if it's a 0, it'll be right here. If it's maybe a 0.2, it'll be here. 0.5, it'll probably show up here. So then you get around 5.5 for your projection. If the random number is, say, a 0.8, it might show up here. So that might be 9 rebounds. all the way to here. So that's kind of how this NORM.INV function works. It just picks a random spot on this bell curve and returns you the number. So this gave us 6 rebounds. We want to make sure, though, if we format this number, see, I formatted it to multiple decimal places. It's 6.89. We don't want to have, you can't get 6.89 rebounds. So what I'm going to do is I'm going to adjust this formula, and I'm going to put the function round in front of it. So you just type in round, left parentheses, here's the value, and at the end we just want comma 0, because that just means we want 0 decimal places. So then when we press enter, there, now it's 4.00. We want to format this so it just shows 4. And every time you do something, this recalculates. So if I just press delete right here, or press delete again, or press enter, this should recalculate. There, see, recalculated on. It probably just kept being 6 for this couple times when I did it. So here we got our simulation of 9 rebounds. So that's great. We got one simulation, but that's hardly enough to make it meaningful. What if we wanted to do 100 simulations? I'm going to take this, I'm going to copy this down, all the way down to right there. There, so we got 100 simulations. These are all his simulations of rebounds. Look, we got 7, 8, 9, 6. There's a 2 here, there's a 3, 4, a bunch of 8s. So these are all the simulation results. I mean, it's good, you got a bunch of numbers, but how do we make this into reality? Let's say, well, first let's do an average, just to make sure that it comes out pretty close to 5.5. So the average, I'm going to highlight this whole range, press enter, and it came out to 5. Now let's put the decimals in there, 5.43. So the average is coming out close to what the projection is, which we want, which we should expect. But we got a whole range, like here's a 0 of rebound outcomes based on his standard deviation. Now let's say we want to look at his odds, and say he's got odds of over 6.5 rebounds is, say, plus 200 or something like that. Is that worth playing? I don't know. Let's figure that out. Let's see how many of these 100 simulations are over 6.5. Well, you can go in here and manually count them. 1, 2, 3. That's the long way to do it. We're going to do a function, and the function is COUNTIF. So what's the range? I'm going to highlight this whole range, comma. What's the criteria? Here you got to do quote, greater than quote, and. So you're building a little like formula. So is it greater than 6.5? Press the end parentheses, press enter. There, 32. 32 times in this range out of 100 would the simulation break 6.5? So did he get at least 7? So now we can look at the odds. You get plus 200 odds, but you're only going to win 32% of the time. Is it worth it? Probably not. You'd probably come close to breaking even with those type of odds, maybe lose a little bit. So this would be something I wouldn't do. But if all of a sudden the odds shot up to plus 250, 32% of the time winning, 1 out of 3 times you're going to win, and you're getting plus 250, maybe it is. But those are the type of things that this simulation will help you figure out. And in future videos, I'm going to show you how to do this on a large scale. So this is great just to do, I mean, this is a lot of work just to get Kevin Durant's rebound numbers, but I'm going to show you how to get this on a large scale. So hope you enjoyed this. Put down any comments, you got questions, and see you in the next video. Thanks.